Okay, can you see my slides?
Yep, we can.
Okay, awesome. Sweet. So yeah, I'm gonna give a quick overview of like the Ethereum roadmap, basically what's happened in the past couple months, what's you can expect in the next couple months. Yeah, and I'll take some questions at the end, so I'll kind of run through these. I just can't see the chat at the same time, so I'll get back to questions after. If you want a copy of the slides, I have a bit.ly, so ETH-July-2021. So there's a bunch of links in the slides. You can kind of get those after at that link. So if we start just like looking back, the upgrades we've recently had on Ethereum, looking back, this is starting to be quite a while now, but it sets some good context. In Q4 of last year, we launched Proof of Stake. So we launched the Beacon chain. And for those of you who aren't familiar, this was basically done in 2 steps. So first we had this deposit contract on the proof of work Ethereum chain where people had to put in Ether up to a minimum amount that would then trigger the go live for the Beacon chain. So mid-October, this Beacon chain contract went live on Mainnet. And it took about 3-4 weeks, or actually, sorry, more like 4 or 5 weeks for us to reach the minimum number of Ether deposited. So after that period, where we had 524,288 Ether deposited, the Beacon chain was set to go live. And there was a 7-day delay planned into that, so that once we hit this number, people have time to get up and running on the network. And today, the Beacon chain's been live since then. Right now, there's over $15 billion and 200,000 individual validators on the Beacon chain. On the ETH1 side, so in Q1 2021, we had the Berlin network upgrade. And this was interesting for 2 main reasons. The first is that it solved the biggest kind of attack vector that we still had on the Ethereum network, which was that some operations were underpriced in terms of gas relative to how long they take a computer to actually execute them. And that meant that if somebody kind of built a malicious block that would just kind of use those operations over and over, they could create a block that would take longer for an Ethereum node to process than the actual block time on the network. And that would obviously slow the network down dramatically. So we introduced EIP 2929 in Berlin, which raised the gas price for those opcodes and kind of patched that security risk. Alongside that, we introduced EIP 2718, which introduced the concept of transaction envelopes, which is kind of a wrapper that we put around transactions so that in the future, we would be able to have more different types of transactions on Ethereum. And this will be, I guess, relevant when we talk about 1559 a bit later. But in Berlin, we kind of introduced this general concept of the transaction envelopes. And the first new type of transaction that we introduced was EIP 2930 style transactions, which are transactions that specify which part of the Ethereum state they access in advance. And the reason for that is that we're able to give kind of a lower gas cost to transactions if they specify which parts of the state they want to access in advance. And this was mostly done to avoid kind of breaking any smart contracts with EIP 2929. So every time we raise gas prices on Ethereum, if there's some smart contracts that kind of depend on those gas prices being fixed, then they'll break because the gas prices have gone up. We needed to raise those prices, but because part of the issue with the gas price being too low was that it's basically the time that it takes the computer to find the spot in Ethereum where you want to access. If you do specify that in advance alongside your transaction, we could kind of prefetch that storage from the network, and therefore it doesn't take as long to execute. So this is why, you know, if you know which parts you want to access, you can use an EIP 2930 style transaction and save a little bit on gas. And lastly, we had a tiny change, which was a bit in the opposite direction. We had a cryptographic precompile, which was too expensive relative to how long it takes to execute. So we were able to reduce the price of that, and that just makes it cheaper for applications that use that precompile to run on Ethereum. So that was Berlin. Now, if we look going forward, the first thing, I should have updated this because we actually have a date now. So next week, around August 5th, we're going to have the London upgrade go live on Ethereum. And this brings a lot of big changes to the network. The first of which is EIP 1559. So you've probably heard about this change a lot in the past. It could make kind of an entire meetup session in and of itself. But at a high level, 1559 is a change to the fee market on Ethereum. It makes it explicit in the protocol what's the minimum price a transaction should have to pay to be included in a block. And this helps just create better estimators for gas prices, so that there's kind of less variance between what different people pay to be included in a similar block. And in order to do that, we need to burn that minimum part of the transaction fee. So this is the other part that people talk about a lot when they talk about 1559. So this has been in the work for over 2 years now. There's a small companion EIP 3198 that comes along with it that basically lets smart contract use 1559 functionality. But it's finally going live onto Mainnet. It's probably the biggest change we've done on Mainnet since the Ethereum Genesis. So it took a lot of time to test, to adapt tooling for. Like Tim said, some libraries are still like just releasing support for it. And it leverages kind of this concept of transaction envelopes that we talked about just earlier, where this 1559 style transactions are kind of a new type of transaction that we introduced on the Ethereum network. And one final thing on this is worth noting, all of the legacy transactions, the current transactions that you see will still work on the network. There's some kind of just smart engineering in how the clients process them that make them compatible with 1559. But if you are using a wallet that hasn't updated to 1559, or you have like a transaction you've signed in the past before 1559 went live, all of those will still work on the network. So that was something that was really important, making sure that things are backwards compatible. The other kind of big change that's coming into London is a change to gas refunds. So gas refunds were originally part of Ethereum so that people would clean up after themselves. So basically, when you add new data to Ethereum, it costs some gas. And the idea was, well, if people then remove that data, we can give them a refund, right? Because they've cleared that data from the network. And in practice, how it's been used, it's a bit different, where when gas prices are low, people would just spam the network and fill it up with basically junk data. And then when the gas prices were high, they could delete that junk data that they'd filled in the past and get a refund for that, so they don't have to pay kind of the gas price. And alongside that, the gas that's executed as part of refunds was not actually counted as part of the block gas limit. So you could have an extra 50% of gas based on the gas limit of a block that was executed from refunds. So right now, just to make this concrete, the gas limit on Mainnet is 15 million. If you include refunds, you can actually execute 22.5 million gas in a single block. So that means that blocks basically vary a lot in their effective gas size, like how much gas they actually execute. And this makes it really hard when we talk about things like raising the gas limits, because not only do you raise kind of the actual gas limit, but you're raising the sort of implicit gas limit that also you need to take into account when you consider refunds. So basically, there are some cases where gas refunds will still be viable. There's a few kind of cases where, say, you want to store something and then unstore it within the same transaction, for example, those will still get refunds. But the vast majority of gas refunds will disappear as of London. After that, we have this other EIP 3554, which basically delays the difficulty bomb. So the difficulty bomb on Ethereum makes mining progressively harder. at kind of an exponential rate. So for most of its life, kind of you can't notice the bomb, but then at some point it goes off and it makes mining harder and harder. So this is happening right now. We're just starting to see it. So I think blocks are usually 13.1 seconds. Now we're at about 13.4, and in a few weeks we would go up to 14, and then a few weeks after that 17, and then 20 and whatnot. So the idea behind this is that you want this bomb to kind of force miners to go to proof of stake at some point where it's just going to be impossible to mine on Ethereum. So because we're not ready to go to proof of stake yet, we're going to push this bomb back. It's happened already a few times in the history of the network. We're pushing it back to December. Either in December, we'll have the merge ready, so we'll be ready to move to proof of stake. But more realistically, we're going to probably have to do one more push for a few months in December so that we can just finalize testing on the merge to proof of stake. And lastly, there's a small EIP we're also adding in London, which basically reserves certain starting sequence for smart contracts so that we can use that starting sequence to identify a different version of smart contracts in the future. And we can kind of use that as an indication in the EVM to introduce some new features so that if a contract starts by this specific sequence, you can execute code in this new way. So this one in London doesn't do anything except just freeze that sequence so that we can then use it to add new features in the EVM. So that's it for London. In parallel to this, the people working on the Beacon chain are also planning a network upgrade, which will be the first time we upgrade the Beacon chain since launch. And there's really three things coming there. The first is adding support for light clients on the Beacon chain. So right now, it's not something that you can do. So basically, every validator on the Beacon chain will just have to attest to some extra data, and that'll enable having light clients on the chain. There's also going to be just some performance optimizations of how rewards are calculated. So because there's so many validators on the Beacon chain performing so many tasks, we don't actually calculate, the plus or minus to the rewards every time they perform something. We just try to keep track of them and then batch update everybody's balance. So there's just some optimizations around how we're doing that. And finally, we're going to increase the penalties on the Beacon chain. So when we launched last December, there was a decision made to lower the penalties for being inactive or for being slashed on the network, just because it was still new and experimental. So now the Beacon chain's been live for almost a year, and it's just time to raise the values to what their normal level should be. So with all that being said, the merge is happening. So once London, which is happening next week, and Altair, which is expected around end of August, early September, are done, the main focus is going to be merging the current proof of work chain with the Beacon chain. And it's worth giving you a bit of background there to how we got to this current roadmap. So initially, we thought we would ship the Beacon chain with proof of stake, which we did, then add some shard to Beacon chain, which would not do anything except store some data. So there wouldn't be any applications on it. And then we would kind of convert those shards to EVMs where you could actually run smart contracts on the Beacon chain, on Ethereum 2.0. And that was kind of the initial roadmap where you would just build everything on this new system and then slowly transition data from the current system to the old one. And as you know, we've been working on this stuff over the past 1 or 2 years. There's been also some progress done on rollups. So rollups are a layer 2 technology which allow to scale Ethereum today. So we don't need basically Ethereum 2.0 to use them. There's already a ton live on Mainnet. You've probably heard about them, Optimism, Arbitrum. And they enable kind of the network to just send a bunch of transactions to this layer 2 so they don't have to all happen on Mainnet. And because we're already seeing this work, and there was a lot of complexity with the original roadmap, there was this idea to instead of having these computation shards as part of the ETH2 vision, let's just keep a single shard, which is our current ETH1, and then use rollups for scaling. And kind of a refinement of this idea that happened over the past couple months is instead of having ETH1 be literally a shard as part of ETH2, we could kind of change things around and have ETH2 be a consensus mechanism for ETH1. And what I mean by this is that ETH1 clients like Geth or Open Ethereum or Besu, they're already used to running different consensus algorithms. So on Mainnet, they obviously run proof of work, but on testnets, for example, they'll run proof of authority. And on private networks, they'll run some other consensus algorithm. So there's already this concept in Ethereum clients of the consensus algorithm being something that's pluggable. So what the current kind of specification tries to do is instead, let's just keep our current EVM chain and have a consensus algorithm switch. So have Get say, well, from this point on, don't use proof of work, just use proof of stake, and delegate everything that has to do with proof of stake to the beacon chain. And this allows just kind of a simpler architecture and better kind of coupling between the beacon chain and the EVM itself. So when we had this idea, I think it was early this year, we wanted to see, can this actually work, right? Is it possible to just like swap kind of the consensus system for these clients? So in May, we had a month-long hackathon where we prototyped this. So we took basically consensus clients, so all the ETH2 clients today, Prism, Teku, Lighthouse, Nimbus, and we bundled them with several of the ETH1 clients, so Geth, Besu, and Nethermind. And we managed to actually get this running on a network where the consensus was driven by the ETH2 clients and the execution, so all of the EVM was running in the current clients. And this was called Rayonism, based on some painting style from Russia. And just to make this, I guess, a bit concrete to anybody who's ever kind of run an ETH2 client, this is kind of a screenshot from the testnet. If you've run an ETH2 client, the first couple rows will feel pretty familiar to you. So the Randau is a field in ETH2. The graffiti is another field in the beacon chain where anybody can kind of put any type of data they want. So we often use it to say what type of client we're running. ETH1 data is a field that is there to basically count deposits to the beacon chain on the ETH1 chain. So this is something that beacon chain clients already do. And then you have this new field, which is what was introduced in Rayonism called execution payload. And this is basically the beacon chain reporting that the execution layer, so that the Geth or Besu or Nethermind engine actually executed a block, so that it reports data around what's the block hash, which was its parent, and what was executed in that block. And this kind of shows that you can get the beacon chain to a spot where it just asks an execution client to run a specific block, return the output of it, and then attests and validates that and finalizes it over time. So this hackathon basically helped us prove that, even though we didn't have all the details figured out, we could use this architecture for the merge. So that being said, there's still a couple open questions. The biggest of which is exactly how we decide to switch over from proof of work to proof of stake. There's different ways we can do it, and there's different security assumptions around how we decide it. The second is just, what does the final ETH1 and ETH2 combined client look like? Do we allow people to mix and match between them? What is the standard protocol we want to use to communicate between them, and so on? The third, and this is probably the most interesting one, is how do you reconcile the concept of finality, which is pretty central in the beacon chain, with historical data, which is a big part of ETH1. So on the beacon chain, anything about 12 minutes or older is considered finalized. And that basically means you can kind of forget all of that data and know that it's never going to change. Whereas on the current chain, on ETH1, we don't have such a concept. So people are very used to having access to like the full history of things and whatnot. So when we merge these two systems that just kind of treat historical data very differently, we need to be mindful about, what properties do we want to keep? Which ones are we okay kind of dropping and whatnot? And then obviously, once we've got the big questions figured out, there's 1,000 kind of technical things we need to do to make sure that this is polished and working and production ready. this is kind of where we're at now. So for some reason, it really doesn't want me to show the checklist, but I promise we do have it. We have like a checklist for the merge that's public. So it lists kind of all these open questions that we need to figure out in more detail. And it also provides some links to some of like the ongoing research and discussion. So if you want to contribute to the merge, this is probably a good place to have a look and be kind of redirected to some specific issues that you can help with. And then finally, this is kind of a visual of what this all looks like. So I know it's like a lot that I kind of dumped on you all, but at a high level right now, we have kind of the ETH1 chain, or what we call the execution layer at the top. We had the Berlin fork. We're just about to have London. We might have another fork before the merge, like I mentioned. If the merge is not quite ready by Q4, we're gonna have to push back the difficulty bomb at least. So that's why it's kind of in this dotted box. But then we will kind of merge. And when we merge, it's basically taking this ETH1 chain and then this ETH2 chain, which is our consensus layer, and putting them together so that there won't be kind of an ETH1 or ETH2, but it'll just be a single Ethereum chain. And then on the consensus layer, we're having an upgrade this summer called Altair. And that's all I had. Yeah, happy to take some questions now. I have probably 5 minutes or so.
Great. Tim, thanks for that. Thanks for the talk. And I sincerely apologize for what
That's
happened
all good.
with the Zoom bombing. It's not the first time, but yeah. Okay, lessons to learn for the future. We do have one question here from Slido.
Sure.
And if anyone else wants to ask questions anonymously, you can do so with this QR code or with this passcode. But first question is, what is the likelihood of 1559 being delayed at this point? And has there been any significant issues on the test nets that is creating any friction?
So basically the likelihood is low. So there was an issue on a test net, they got fixed, and we agreed to not delay it because we didn't feel it was necessary. So basically what would cause 1559 to be delayed is probably another issue being found on the test net in like the next week. But barring that, I don't think it'll be delayed.
Okay. And if anyone else has any questions, I can't really see the Zoom chat box right now. Or, if you want to ask a question directly, feel free to unmute yourself. Philip, Wyatt, I know you guys had some questions, I believe, for Tim in terms of Web3.js.
Hey, Tim. First of all, thanks for actually coming on here. I know you're a busy guy coordinating all the all core devs kind of calls and stuff like that. I just wanted to ensure that, is there any sort of other large hard forks that are coming down the pipeline before the merge, and just looking to see like what the opinion is on that, because like the hard forks do create significant workloads on a bunch of the clients and implementers. So if there's anything like potentially that we should be aware of within the next like even 6 months to a year, it would be great to sort of.
Yeah, that's a really good question. So basically, the answer is maybe, and there's kind of two paths here. So the next thing we want to do is get some test nets up and running for the merge that people can play with, right? Because like you said, client teams, there's a lot of work to get that done. So we obviously want to prioritize that work. And then the other bit is there's a lot of work that infrastructure providers like Web3.js, for example, need to do to actually add support for that. So based on how long the kind of infrastructure and tooling providers need to set things up, we might have the time to have another feature fork between kind of having testnets and having them merge on mainnet. I think that's kind of the only case where it happens. And the EIPs that would be included would probably be pretty minimal from like a architecture support standpoint. but there are some EIPs that people have been working on for a long time that they'd like to see on mainnet. So yeah, there's just a lot of value in getting those out if we can. But there, I'd say it's more likely than not there is no hard fork between kind of London and the merge. Yeah. But if there is, it's basically because we have a very extended period of merge testnets, and we feel we can just fit a hard fork in before we merge on mainnet. I see Antoine has a question in the chat. So far, yes, we're aiming any combo of client pairs to work together. The JSON RPC spec is still being worked on. So if you have any strong opinions about that, you can join the merge channel on the ETH R&D Discord. Yeah, I think that's one area where we need to figure out exactly what's the right approach and whatnot. The beacon nodes following ETH1 nodes also need to run validator and voting. So basically, I'm not sure I understand that last question, but basically you can run an ETH2 or a post-merge node without being a validator, right? You can be just kind of a listening node on the network. But if you are a validator, you're going to need both after the merge. You're going to need to be able to produce and validate ETH1 blocks.
Right. So let me try to explain. I think it's a little overweight as an architecture right now, because you're having a full-on ETH1 client. It's going to run on your drive. It's going to use some of the hard drive, and then you have a full-on ETH2 client, which has all the abilities to host validators, connect to validators, allow voting, and all that. And just for the simplicity of you're just trying to do ETH1 work, would it be possible to have a subpar version of an ETH2 node that just does the very minimum of following the chain, allowing you to know what's final?
Yeah, that's a good question. So I think they are working on light clients for the beacon chain, and I'm not following that work specifically, but I feel like that would probably be the #1 use case, right? It's like if you want to run just an ETH1 node, and not have a full beacon chain client, yeah, maybe it makes sense to have a light client. But yeah, I'm not following that super closely.
Okay, yeah, it's just an idea. It's just
thinking I think that's a really good point though. Yeah.
Cool. Okay, thanks.
Cool. And I probably have the time for one more question if there's another question. Oh, Hudson has a question.
Go ahead. Do you want me to unmute you so you can ask directly? Here, let me do that. Where are you, Hudson? There we go.
Tried to type it up, but it was kind of long. So, hey, Tim, and other Tim. Can you speak to some of the efforts going on by Trent Van Epps and others, maybe like Pooja and stuff, to reach out to more ecosystem participants and dApp developers and get their input on some of this EIP work and kind of that outreach and the latest on that kind of effort?
Yeah, that's a really good point. So the EF has historically been bad at reaching out to the broader community with regards to protocol changes. And so we hired somebody to fix that, which is Trent. So Trent's role is basically acting as kind of a liaison between the protocol teams and the application teams and infrastructure teams building on Ethereum. So one thing we started during London is to have just calls that are kind of focused on these folks who need to not implement the changes, but add support for them. We have one coming this Friday as well. I think it'll be our 4th one about London. So this is something that we want to do more and more of. And we started tracking also, which libraries are ready with support for 1559 and whatnot. This was the first time we did it. So I think it was good to do it. We probably started a bit late in the process. And this is why for the merge, we intend to start kind of earlier and have a longer kind of period between when the actual protocol changes are done and when we go on mainnet, so that all of this, basically all of the ecosystem has time to adapt and whatnot. Yeah, so if you're interested in following that, yeah, we have a call this Friday at 1400 UTC, which is 10 a.m. Eastern time. The Ethereum/PM repository has all the information there. And on that note, yeah, I have to run. But yeah, thank you very much for having me. This was great.
Hey, Tim, thank you so much. Really sorry about the Zoom bombing. Have a great
It's all good. Cheers.
Cheers.